Hi guys, Professor Burns here. Let's take a look at the video for section 2.1, which is looking at variation with numerical data. Make sure at this time that your cell phones are put away, out of sight, out of mind. Want to make sure we can focus for the next few minutes. Have your guided notes in front of you and make sure you're writing everything down as well as listening carefully to what I'm saying. We'll try to keep these videos fairly short. So we're looking in this chapter, or at least starting out in this chapter, looking at numerical data. Remember that numerical data is data that involves measurements or counts of some kind. The objectives we're going to look at are exploring how we use a distribution for numerical data, dot plots, relative frequency and histograms, and what that distribution looks like, how we describe that. So when we have a sample of numerical data, we call that the sampling distribution, and that's the distribution or visual display that shows us all the frequencies for the different outcomes for that particular sample. There are three components that we're interested in describing when we talk about a numerical distribution. The first is the shape, and literally just like it sounds, the shape. How is the data shaped visually? Usually we'll describe it as either symmetric or skewed, and we'll talk more about that later on. The center, or what we would describe as a typical value for the data set, what is a good representation for the data set, and the variability, which we can also think of as the spread horizontally, literally, how spread out are the data points? Are they clustered close together, or are they pretty far apart? Observe that distributions record all observed data values for a given sample of data, and sometimes looking at raw data is really tough to see patterns, and so for that reason we usually put the data on some sort of a visual display like a graph, or we may use what's called a frequency table. So a frequency table lists all data values for that particular sample along with their counts, how many times each one occurs. And sometimes patterns are still difficult to see, but usually that kind of can get us started working with the data. So there's two main types of graphs we're going to use for numerical data in this course, dot plots and histograms. And when we're looking at the graphs and we're looking at data using one of these graphs, we want to follow a two-step process. First, we want to visualize the data. We want to choose a graph or use a graph that effectively summarizes the data visually, so a graph that's appropriate for the data. Various visual representations captures different aspects of the data, but all of the graphs must record all of the data values for that sample and indicate the frequencies for those data values. And as mentioned above, we want to summarize the data using the shape, the center, and the spread. So once again, the shape, either whether the data is symmetric or skewed. And we also may want to talk about the modality of the data, which again, I'll describe what that means later on, so don't worry about that right now. Just know that those are the things we want to consider. The center, what would be a typical representation for the data set, and the spread. So literally the horizontal variability or spread. I tend to use those words variability and spread interchangeably, and you'll hear me say that in the next few sections. So let's start with a dot plot. What does a dot plot look like and how does that work? So dot plot is a visual representation or graph that records all of the data values on a number line with a dot above the number line representing each individual data value observed. So what would be an example of a dot plot? Now I don't have any necessarily in your notes here, but let me just show you a quick picture to give you a little idea of what we're talking about. Here's one, I just did some Googling. Here is one where we're looking at heights. So you can see that the heights in this data set range from somewhere around 50, maybe 50 inches to about 80 inches. And you can see each individual person or whatever this measures. I assume this is people, could be animals or something, I don't know, but each individual data value is recorded in the data set. You can see every individual data point. And that would be basically what a dot plot would look like. You can see trends in the data. This looks to me like it's relatively symmetric. You can see the frequencies for each individual data value. Now, what are some advantages to using a dot plot? So as I mentioned, it shows those individual data values. And it also helps us see the shape of the distribution. So the shape is apparent, I guess. So you can see pretty quickly that it's either symmetric or skewed, or if it's multimodal or whatever. A couple disadvantages. Probably the biggest one is that it's not good for large data sets. You can see that if it records every individual data value in that set, if you've got really, really large, like 1,000 data points, that's a lot, and that gets pretty messy on the graph pretty quickly. So in that case, we would probably use something instead called a histogram. So a histogram is where we group data into different intervals, which are called bins, and the width of each interval is called the bin width. It shows us the frequencies of data that falls within each bin, and we can adjust the bins depending on what numbers we're working with in the data set. Each rectangle in a histogram has the following properties. The bins are consecutive, so they go in numerical order from left to right. The first value in each bin is recorded on the horizontal axis, and the height of each rectangle corresponds to the frequency for that particular bin. Let me get you a picture here so we can see an example of what a histogram would look like. Here's just a quick basic example of a histogram. Now this is a pretty generic example. They didn't tell me what this represents, but you can see each bin has a width of 10 units along the x-axis. So you've got 0 to 10, and really 11, the way they've broken this up, it goes 0 to 10, and then 11 starts the next bin width. So 11 to 20, and then 21 starts the next bin width. And then the frequencies are this way. So along the same lines as a dot plot, you can see the shape of the graph pretty quickly, and you can see the frequencies within each bin. A couple of other notes on bin width. So a width that is too narrow will show too much detail. Whereas on the other hand, if the width is too wide, it shows, or it hides the detail. Basically doesn't show enough detail. StatCrunch is what we're going to use to make these graphs, and StatCrunch will default to whatever bin width is appropriate for that data set. A lot of times it'll just say 5 or 10 or something along those lines, but sometimes we want to play around with it and see if we can find any patterns, or if it's easier to see patterns or trends with different bin width. A few advantages and disadvantages to using histograms. So some advantages is that they are good for a large data set. So if you have a lot of data, thousands of observations, then a histogram is much more preferable over a dot plot. It helps us see the shape, so we can see the shape of the data pretty easily. And it's also easy to spot outliers with a histogram, and actually with dot plots it is too, but it's easy to spot outliers, and we'll see some examples of that in class. A few disadvantages is that it hides individual data values, so it's hard to see specifics. If there's a specific value you're looking for, all you see are those ranges according to the bins. And the distribution, the shape of the distribution is affected by the bin width. So sometimes we can change the bin width or make it, like we said, too small or too wide, and that affects what the shape looks like. All right, so we will practice these in class. Be sure you bring your notes with you tomorrow, and I'll see you then.